Hi everyone, welcome to our channel CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithms, then this is a one-stop destination for you. Every week we'll post CodeChef problem explanations, conceptual videos on various programming paradigms and also conduct live problem solving sessions. But before we get started, here's a reminder to hit the subscribe button if you haven't yet already. Great, now that you have subscribed, let's get started. Today we are solving the problem diagonal movement, which is a starters 14 problem. So let's see the problem statement. Here the problem statement says that there are two coordinates. There is a single coordinate given to us on a 2D plane, and we have to find out that whether it is possible to reach from 0, 0 coordinate to this x and y coordinate. Whether it is possible to reach this coordinate or not. But the restriction is that we are given only these four possible moves. So this I and j that you see, you can consider I as x and you can consider j as y. So that means these are the only possible moves that are there, right? Now to understand this question, first of all, what we can do, that we can consider that x and y both will always be like absolute. We can take the absolute values of both x and y, because whatever we will try to do, we can try to prove it on the positive side of the coordinate rather than also taking the negative side. Now after having said this, now if we take any particular coordinate, say I comma j, right? So whatever whatever is the parity of this I comma j, like I plus j, and if I divide it by mod 2, if this I do this, and after that pick up any of the four operations, like if I pick up this particular operation I plus 1 comma j minus 1. So if we change this particular operation to I plus 1 comma j minus 1, now what will be the parity of this operation? If we calculate the parity of this operation, it will again be I plus j, because this plus 1 and this minus 1 is going to get cancelled, right? So it will be equal to this operation. Now the next thing that I want to say is that for all the other operations, if you observe, then the parity will remain the same. Like for I plus 1 and j plus 1, plus 1 and plus 1 is getting added. So if I plus j is originally even, then plus 1 and plus 1 will also just make it even. It will never make it odd, right? So this will remain the same. Now why have I taken mod 2? Why have I taken this parity as even? Because initially we know that the starting point of the coordinate will be 0 comma 0, means this is the starting point from which we have to transition to x comma y, that is given to us. Now what is the parity of 0 plus 0? So 0 plus 0 is equals to 0, which is even, right? So that is why we have to check. So in this problem, if we just check that x plus y is modulus 2 is equals to 0 or not, it means x plus y has to be even. In that case, it will always be possible for the answer to exist, meaning we will be able to move from 0 comma 0 coordinate to x comma y coordinate, else it will never be possible because of this parity thing that I've just explained. So I hope that you have understood the problem. This is it. This is just about the problem. And now let us see the input, output and constraints. So the first line of input contains t number of test cases, and for each test case we have a single line of input x comma y. Then the output can be you can print yes if it is possible to reach x comma y from 0 comma 0, or you can print no. The constraints are large, so you have to take a data type which can take large values, but the complexity will be order of 1. So guys, the code, in fact the code will be a very simple one in this case, because these are just the inputs and I've taken long int here because of the large values, and you're only supposed to check whether x plus y is even or not. If it is even, then answer would be yes, else the answer would be no. So that's it. That was the problem, and I hope that you have understood it. If not, then please post your doubts in the comment section, and we'll see what we can do to help you.